Hello, good morning everyone. Next we'll see the types of arrays. As we have seen in a general array, either it may be stored in an vertical way and the horizontal way. Here in these two types of array, we have three types of array. First one is 1D, that is one dimensional. And 2D, two-dimensional array. And ND, n-dimensional array. Coming to the first one, 1D, generally we have been seeing that one normal array. In the same way, this is also represented either in an vertical way or the horizontal way, and the syntax will also be same and the storage of that elements will also be same as a normal array. Just now we have seen that the syntax and the how that memory representation of an array same will be for an one-dimensional array. Let us see about this two-dimensional array. Here the syntax two-dimensional. Here the name itself indicates that will be stored in and two ways, that is rows and the columns. Let us see for that syntax of this 2D array. That is data type, array name, and here in the single dimensional array it will be only one subscript, but in the two-dimensional array there will be two subscripts, which one will be represents the rows and the another will represents the columns, and that will be again initialized to some elements. Whatever the element, the size, that much of elements we will be storing in that array. Let us see with an example the same data type as an integer type data type. What type of data type you have been taken here? The same type of data that should be stored in an array. Now, if you take here integer and you are storing some character data type, it won't be allowed. That means an error in our storing the data. Here, the data type, whatever you are taking here, the same type of data should be stored in an array. Now here I am taking the integer data type and the array name is X again, and here I am taking 2 rows and the 3 columns per suppose, and the total elements that has to be stored is 6 elements, and that elements are and 6. These are all the elements. Let us see with how in a diagrammatical representation of this 2D array, how that elements will be stored in an array. Here 2 rows, that is 2 rows and 3 columns. This will be represent X equals 2 and these will be of 0. As I have told you, the array always starts with 0. 0 and 1 for the rows and 0, 1 and 2 for the columns. As my size is 3, as it starts from 0, 1 and 2. Okay, and that elements will be stored as 1, 2, 3, 4, 5 and 6. This is the way the elements will be stored in a two-dimensional array. Let us see that memory representation, how that data will be stored in an memory. Memory representation of a two-dimensional array. The array name will be same for all the rows and columns, and in the initial element 0, 0, this is row and this is a column. Row and the column, and that element is this one, 1. And X of 0, 1. Here the element is 2. X of 0, 2, the element is 3. And X of 1, 0 here, the element is 4. And X of 1, 1, the element is 5. And the X of 1 and 2, the element is 6 here. Like this, the elements will be stored in the two-dimensional array. The memory representation will be represented like this. That rows and the column, the intersection or the combination of this row and the column, the element will be represented. Here, these basic operations that have been performed on this array are first, creation, insertion, deletion, updation, search, and traversal. These are all the 5 basic operations that will be performed on the array. First one, creation. Creating an array, either it is an one-dimensional or a two-dimensional array, and inserting that elements into our array, and deletion process. Deleting, using that index number, we will be performing this insertion and the deletion. And updation. After performing these two operations, this updation should be done, and after that we will be searching a particular element in our array, and also the traversal. Traversal is nothing but we are traversing throughout the array how many elements are present in our array. Next type of data structure, previously we have learned about this array. First type of linear data structure where the data will be stored in a sequential order, that is array. And another type of data structure, the second type, that is a stack. Stack, it is also one of the data structure coming to a non-primitive data structures where the data will be stored in a sequential order, and also this stack where the data will be stored, and that is LIFO, that is last in first out. Last in first out. Here the data will be inserted at an one end. Let us see the structure of a stack. That will looks like this. A stack will look like this, and what are all the operations, basic operations that will be performed at that one end, that is called as an top of stack. And the operations, that is insertion, called as push, and deletion, called as pop. And to see all these file insertion and for deletion, we will check two conditions, that is full and is empty. First, while we are performing this insertion, that is push operation, and the pop operation is performed on this stack, we will see these two conditions, that is full and the is empty. If it is full, the insertion is not possible. If it is empty, the deletion operation is not possible. Why? Because if it is full, the stack is full. Already it is full, there is no space in our stack there. So the insertion is not possible to insert a new element into our stack. So that's the reason we cannot insert a new element into our stack. So the push operation, for if the stack is full, it is not possible. And the deletion operation, pop operation. For the deletion, we will be using this pop operation. For this, we will check it is empty. If it is empty, we cannot delete any elements from our stack. So that's the reason whenever we will perform that insertion and the deletion operation, that is push and the pop, we will check these two conditions, is full or is empty. And also to get what is the topmost element in our stack, the next operation is get top. Get top is a function which will return which is an topmost element on the stack or ready to delete. Let us see with how these elements will be inserted into our stack. The push operation is performed in our stack. Now this is a stack. Suppose A is the name of a stack. Now I am performing this push operation. While performing these elements, we have to have some elements, that is 12, 10, 1, 5 and 18. These are all the elements that I should be inserted into my stack, that is A, and this push operation is performed at the one end, the stack. These operations, whatever operations we will be performing, either the push, pop, get top, and that is empty and the is full, these all operations will be performed at that only one end. That is, this is an end where these operations will be performed. Now, one by one, we will be inserting our A push operation. Using this push operation, we will be pushing each and every element onto our stack. The first element is 12 here. This is a 12. The push operation is performed and this is inserted here. And next second element, that is 10. Here the 10 will be present. And next is an 1. Again the push operation is performed and 1 will be inserted into our stack. And the next element is performed 5. And then 5 will be inserted. And next the last element is 18. And 18 will be the topmost element in our stack. So 18 is an topmost element that is present on that stack. As I have told you, it will perform last in first out principle. The pop operation, deletion operation is performed on the stack. That is, whichever is inserted last, that will be deleted first. So the 18 that is inserted last, that will be deleted from our stack last. So while performing this pop operation, which is the topmost element, that will be popped out, which we can perform on our stack. The 18 I have deleted. Next coming to a next element is 5 here, the topmost element. The next element is 5 here. Next again performing the pop operation. And the next element I have popped here 1, and the next element I have popped here 10, and the last one is 12. So 12, which is inserted first, that has been deleted last here. So like this, the operations will be performed on our stack. These 5 basic operations: first, insertion, deletion, and the get top. These 3 are the basic operations, and to perform these 3 operations, we will be checking 2 conditions, that is empty and the is full. Next type of data structure, that is queues. Here, unlike the stack where we will be performing those operations on the one end, here in the queue we will be performing it on the both the ends. Both the ends, and it will follow the principle FIFO. That is, first in, first out. Whichever the element inserted first, that will be deleted first. So let us see with an structure of a queue. This will be looks like this. That is, at the both the end it will be open, and the insertion and deletion will be performed at 2 different ends. Unlike the stack, we have been performed that operations only at the one end, that is top of the stack. But here in the queue, we will be performing it on the 2 ends. That end, whichever that insertion it is done, that end it is called as a rear, and the deletion, where the deletion operation is performed, that is called as a front end. Front end. And the operation insertion, it is called as an NQ. Insertion operation. In the stack, for the insertion we have been used the push, and for the deletion we have been used the pop. So in the same way here in this queue, for that insertion we will be using the NQ operation, and for the deletion DQ. DQ will be performed on this both the ends. This is the rear end where that insertion is done, and this is a deletion which is done at the front end. Whatever the element inserted here in that first, it will be placed here, and it will be deleted first. So this queues will uses this first in first out principle for these operations. So let us see with an element. These four are the elements that has to be inserted into our queue. First, the first element, rear end. In queue I am performing here. The first element is 15 here. Insertion 15 I have done, and insertion from the rear end I have inserted here. And next I have inserted 1, and next I have inserted 3, and next I have inserted 4. Now, in the stack, we have been told that the topmost element on the stack that will be measured at the top of the stack. But here, as we are performing at both the ends, which is the element ready to delete from the queue, that element should be on the next element, whichever is deleted. That operation it is called as get front. As we are deletion operation is performing at the front end, so we have been using that which element is ready to delete at that front end deletion operation. DQ is performed, that is called as an get front operation to get that which element is ready to delete at the queue. So now we will perform the deletion operation from the rear front end. The deletion DQ will be performed. First, whichever the element have inserted first, that will be deleted from my queue first. So that's the reason it will uses this FIFO, first in, first out operation. Here also we will be checking while performing this insertion, deletion and the get front, we will be checking the two conditions again. If is full and is empty. These two are the condition we will be checking while insertion and the deletion that has been performed on our queue. While inserting an element in our queue, we will be checking if the queue is full or empty. If it is full, already full, we cannot insert the new element into our queue. So it cannot provide any more space in our queue to insert a new element in our queue. So that's the reason the insertion is not possible if that queue is already full and is empty. If we will be checking this condition, for the deletion operation should be performed. If already the queue is empty, there is no elements to delete in our queue, so the deletion operation is not possible for that if that queue is empty. So for that reason, for insertion and the deletion and the get front, we will be checking these two conditions, that is full and the is empty functions. Next, till now we have discussed about this non-linear data structures. Three types we have seen about the array, queue, stack and the queue. Next, the last type is about the linked list. The last type of linear data structure, that is an linked list. This is different from these three. Compared to this arrays, stack and the queue, these linked lists are different from these three. Here that the same. The list means the list of elements that are linked, through which that will be linked means using the address of the next node. Okay, here the node. What do you mean by a node? Node here in our linked list, it will use a basic data structure, that is a node structure. This is called as a node, which consists of two parts. That is the two parts. The one is an data part or an element or a value, you can call it as value, and this is an address or a link that will be providing, which will be linked to another node present in our linked list, where the address of the another node will be represented here. Here this is a node structure to create the list of elements. Depending upon the list of elements in our list, that the node structure will be created separately and the elements will be inserted and the address will be provided to our linked list. Let us see with an example how this linked list will be done. Now, suppose I have this 14, 10, 5, 8 and 16. These are all the elements I have to inserted in our data structure, that is linked list. To this, for each and every element, I have to create a separate node and I have to insert some value there and I have to give the address. And for suppose this 14 has been at the address of 100 and 10 is at the place of 101 and it is 2 and it is 3 and it is 104. These are all the addresses. Address or link of the next elements. Now let us see with this linked list how these elements will be represented in a form of a linked list. So first we have to create the number of elements present in our list, that many number of nodes. I have 5 elements in my list, so I have to create the 5 nodes in my list, and each node consists of 2 parts here, and also I will give here the data part, no? So 14, 10, 55, 8 and 16. Here I will insert my elements, and how come we will be knowing the next element is 10 in the memory? Why? Because of this address. Here the 14 will be in an address of 100, where the first element, the address will be in an header part. This is called as a header. So this 14 address is 100 and that is called as header, and this 10 is at the address of 101. This 101 will be represented here, that is 101, and this will be linked to this one. Whenever in the memory we are searching, first we will go to that address of 100 where the 14 will be present, and the next node, how come you know that 10 is present there? Using this address. Whenever the memory it will go to this address, it represents that the 10 is present at the next element. And again the 5 address is 102. This 102 will be represented in that 10 address, and this will be linked. This link is very important. That means the next element whichever is linked in our linked list, it will be representing using the address of another node or a next node which has been present. So here the 8 is present at 103 and this is address will be represented here in the 5, and this link is created. And next the 16 is present at an 104 address, and this address is represented at 104 and the link is created. And the last node, as it is an end of our linked list, only have 5 elements, so that the last node represented as a null. There won't be any connection, no? That as it is an last element, it doesn't have any elements rest. If I have any element again, I have to represent that address here, and I have to first create a node, represent an element, and that address will be represented here. As the 16 is an last element in my linked list, so the last element, the address will be represented as null. Here, this is a way we will create our linked list using the list of elements. First, we have to create a node structure with a 2 parts, that is data part and the address part, and how many elements present in my list, those many node structures have to create, and that elements will be inserted, and using that address the next element will be linked in my linked list. Here also the basic operations are basic operations that has been performed on the linked list are: first, we are creation, that is creating a node structure there, inserting that elements and linking to that using that address of that next node. That is an creation. Next, insertion, deletion, traversal. These are all the 5 basic operations. First of all, here also we will check while insertion and deletion. Here we generally we will be checking about the is full or the is empty. Here deletion operation, first we will checking if it is empty. If there is no element, so the deletion operation is not possible here. So only for the deletion element, if we will be checking that the list of elements in my linked list, the link is present or not. If it is not, we will be creating some list of elements, and that insertion is done there, and the deletion operation is performed. And next, traversal. Using this header, we will be traversing or an temporary variable. We will be traversing throughout the elements present in my list from starting to the ending, and we will be searching what are all the elements present in my list. These are all the basic operations performed on our linked list. Now, till now we have discussed about the linear type of data structures where the data will be stored in an sequential order. We have been seeing the 4 types: array, queue, stack, and the linked list. Now we will be seeing about the non-linear data structure, where the data structure or the elements whichever has been stored here, that will be not in an sequential order or in an random format. The data will be stored not in sequential order. It may take any of the order, it will be storing. Here in this non-linear data structures, we have 2 types of data structures, that is trees and the graphs. We have 2 types of data structures here. Come in the non-linear, where the data will be stored in a random format. In that, trees and the graphs. Generally, in general, the tree structures will be follow as root, branches, and stem, and leaves, and the fruits. Right? In the general normal tree, this is a format from down to the up. But in our non-linear data structure, it will follow the hierarchical form. The data will be stored and it is from top to down. That is first root, and as it is an hierarchical form, or it is having the relationship between those nodes present in our data structure. Here the root node and the parent node and the child node and the leaf node. Here this will follow these types of structure in our tree. Tree is a non-linear data structure where the data will be stored in a random format. It will be used as an hierarchical form. The data will be stored and there is a relationship between those nodes. In which way the data will be stored means, first that is a root node, and then comes the parent node, and then comes the child nodes, and the last one is a leaf node. Let us see the structure, how that will be in a tree. See, this is a node here. This is a root node. Root node and B and C. These B and C are the child to A. A is a parent to B and C. Here A is acting as a root as well as a parent to B and C. Again we have this structure D, E, F and G. This is also here B is acting as a child and a parent for D and E, and C is also acting as a parent and a child, parent for F and G and child for A. This is a left child and this is a right child. This is the left child and this is the right child for A. For B is a parent for D and E, and C is a parent for F and G. And also I have sort of that last node, I have H, which is represented as a leaf node. Whatever the nodes which do not have the child nodes, those are all called as a leaf nodes which are present. See, for suppose not only have a H here, the D, F and G, these 3 nodes are also doesn't have the child nodes. That's the reason those nodes are also called as a leaf node. Those are not the parent nodes, those are all the leaf nodes which doesn't contain any child here. This is a representation of a tree structure where the data will be stored in a random format and which have a relationship, and A, B, C, D, E, F, G and H are called as a nodes, and these are called as which will be connecting these nodes called as a edges. edges. This is an structure of a tree, and here we will be performing the basic operations of this tree. Basic operations are insertion, deletion, traversal. These are all the, in our data structure, we will be performing these 5 or 3 types of basic operations that have been performed on all the types of, either it may be a linear or non-linear, these basic operations will be performed. That is insertion, deletion, updation, retrieval, traversal, all will be performed. These are all the insertion, inserting an node into our tree, and deletion, deleting a node from our tree, and traversal. This will be done in 3 ways. Traversal. This traversal, that is the way of traversing our tree, this will be done in 3 different ways. That is pre-order, post-order, and in order. This traversal is done in 3 different ways, that is in order, pre-order, and the post-order way this traversal will be done. This is all about this 3 type of data structures which comes under the non-linear data structure here. Next type of non-linear data structures, now we have discussed about the trees, and the last one is about the graphs. Graph is also comes under the non-linear data structure, where the data will be stored in an random format, and also G, it is an combination of vertices and the edges. This graph, it is called as, generally the graph will be represented as vertices and the edges. The representation of a graph, it is like this. These are all the vertices. This is also a vertex. This is also a vertex. These are all the vertex present in my graph, and whichever this is connected, the connection between these vertices, those are called as a edges. A, B, C, D, and E. The representation of a graph will be looks like this, and also here the graph where it will be, we have 3 types of graphs, that is 3 types of first one bidirectional, unidirectional, and weighted graph. Now here in this first, coming to this bidirectional graph, this is an bidirectional graph where AB is equals to BC. So whichever the path you will be traversal from A to B and B to C, that is equal. So that's the reason AB is equals to BC. Whichever the node or a edge you will be taking to travels from A to C are different path. Here while traversing from A to E, it will choose as a least path from A to E to traverse. From A to E, whichever is the least path, it will choose that one. Now, let us see what are all the nodes from A to E. Those are all the path. From A to B, we can traverse. B to E, directly we can go. And now, what are all the possible ways to traverse from A to E, we will be seeing now. A to C, C to D, D to E. And A to C again, C to D, D to B, B to E. Next, A to B, B to D, D to E. These are all the 3 different ways we can traverse from A to E. While traversing, it chooses the shortest path and the least path to travel. Which is the shortest path means this is the shortest path to traverse from A to E. It will chooses this path. Why? Because the time taken to traverse that is very less, time complexity, and also it is only one intermediary node through which the element has to be traversed. So here that is comes under the bidirectional graph. Coming to the unidirectional. Unidirectional means that is called as an directed. Here AB is not equals to BC in the directed. In the directed graph, AB is not equals to BC. Why? Because the direction is mentioned here from A to B only. We cannot traverse from B to A. Why? Because some direction is given here. In that direction only we have to traverse from whatever the direction or whatever the path we will be choosing. In that direction only we have to traverse from A to C. Now we will be seeing the same where the vertices are directed. Let us see from A to E how that traversal will be done. Here again A to B is going and B to E, and A to C, C to D, and D to E. Only these are all the two possible ways or three possible ways: A to B, B to D, and D to E. These are all the three possible ways we can be traversing from A to E. That is directed. So it is in the direction only that the path should be traversed. Now coming to a third type, that is weighted graph, where weighted graph is nothing but we will be having some value or data, that is this one, 5 and 1 here. So we will be having some value on our edge to traverse. So here this from A to B, the cost or that weight is 1 here, and from A to C that is 2, and C to D that is 3, and B to D it is 4, and B to E it is 5, and D to E it is 1. Using these are all the three different ways. Bidirectional means no direction here, and the directed graph, that is some direction will be given there. We have to follow the direction to traverse from each and every node in our graph. And weighted graph, it is nothing but on our edge it will be consisting some weight or a cost to traverse from A to B or whatever the node present in my graph. And also here the basic operations are same here. Insertion, the basic operations performed on the graph are insertion, deletion, and the traversal. This traversal will be done in two ways, that is DFS and the BFS. Using these two methods we will be following depth first search, breadth first search. Using these two methods we will be traversing our each and every node present in our graph. Here these two methods will be, after performing these two methods we will be getting a spanning tree as our graph, which will cover all the nodes in our graph but a least number of edges. That is an aim of our DFS and the BFS. Why? Because with a less cost all the nodes should be covered with a less number of edges. That is an concept where these are all about the non-linear data structures, that is trees and the graph. This is all about the introduction to the data structures. Here we have been seeing all the definitions about the what is the data structures, characteristics, and what are all the different types of data structures, that is primitive and the non-primitive. Primitive in the primitive we will be having the 4 types of data structures, that is integer, character, float, and the double. And in the non-primitive we will be having the 4 types: two types, that is linear and the non-linear. In the linear we will be having 4 types and the non-linear we will be having the 2 types. We have been discussed all the types in our class, that is arrays, stack, queue and the linked list in coming in and linear, and in the non-linear we will be discussing about the trees and the graphs. With this we have completed our topic about the introduction to our data structures. Thank you.